Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about Norris type 1 reaction. What is Norris type 1 reactions? Look at here examples. Acetone undergo light reactions. It gave excited molecules, and then after fragmentation, you will get the acyl radical and methyl radicals. So what happened here? Cleavage of alpha carbon carbon bond, and this is the key for the Norris type 1 reactions. Now you can see then second steps, how acyl combine together forming diketone and acyl combine together form diketone and acyl groups further break and methyl radical form, and two methyl radicals combine together form ethane. So the key steps in this reaction is alpha cleavage. Now you can see the another examples, which is unsymmetrical keto groups. Here also acyl and ethyl radical form, and then again you can see how this compound give the acyl radical and dialkyl propyl radical. So here also alpha cleavage occurs between carbon-carbon alpha cleavage. So this is the examples of SN1 type reaction. Now in Norris type 1, and I have discussed about Norris type 1 reaction, then Norris type 2 reaction. Here what is the difference? Look at here the reactions. Now here is also keto groups, but the positions of gamma is also important, because Norris type second reaction focus on gamma hydrogen atom. You can see here in 18 how gamma hydrogen abstract by oxygens and forming 19, which is radicals. So this compound is diradicals, and then after fragmentations between carbon-carbon, there are formation of 20 and 21, which is resonance stabilized. So what is the difference between Norris type 1 and Norris type 2? Norris type 1 focus on alpha cleavage. Norris type 2 focus on gamma hydrogen abstractions. Now you can see the next examples. 19 also have gamma hydrogen. If gamma hydrogens replace with the deuterium, so CD bond will break. Now you see the products. So look at here. You have one substrate 22. It has options type 1, Norris type 1. There is a product formations, and type 2 there is a 3 product formation. So this is the chemistry of Norris type 1 and Norris type 2 reaction. Just remember. Now here you can see the photochemical reaction of cyclic ketone. If you have ketone like this, then again cleavage of carbon-carbon forming radicals, and there is a two path from here, 23 and 24. So again you can see the another examples, remove CO and then cyclization occurs. Now you know indenols have been reported to form on the irradiation of aryl benzyl ketone. Formation of a stable benzylic radicals explain these observations. Look at here the light reactions. Now you can see these examples also very important, how cleavage of carbonyl carbon, formations of radicals, Now there are two products, ketene and unsaturated aldehyde. Ketene form this cyclized product and unsaturated aldehyde form this product. Now, my friend, Paterno-Bucchi reactions. What is Paterno-Bucchi reaction? This is also very important reaction. Carbonyl compound yield oxetane. This four-member ring contain oxygen is oxetanes on irradiation in the presence of olefins. If you have this carbon-carbon double bond, if you have the carbonyl compounds, they undergo photocycloaddition and it known as Paterno-Bucchi reactions. See the another examples, formation of oxetane. See another examples, how double bond and carbonyl compounds forming oxetane. So this is the Paterno-Bucchi reactions. You can see cis or trans 2-butene undergo irradiation. So there is a here difference between stereochemistry of oxetane. You can see the acetone and forming the oxetane. That is very important for NET examination. Now last example you can see triple bonds and carbonyl forming oxetane. Now photochemistry of alpha beta unsaturated ketones. Look at here. This CO is conjugated with double bonds. In presence of light, N to pi star transition occurs, undergoes singlet excited state, then triplet excited state. You can see here formations of cycloadditions and photocyclodimerizations. So you can see there are two products after reaction with alkene and alpha beta unsaturated ketone gives cyclized products 4 cycle, and there are two products major and minor. But this is not oxetane like Paterno-Bucchi reaction, so don't confuse. Here you can see the reaction with alpha beta unsaturated ketone and double bonds forming 4-member ring. Next example you can also see here, alpha beta unsaturated ketone react with acetylene, it gives the cyclized product 4-member rings. Two molecules alpha beta unsaturated ketone, it gave the two product 29 and 30. You can see here dimerizations. So this is the example of ketones and alpha beta unsaturated ketones and alkene reaction. Now photochemistry of olefins. You know olefins means double bonds. Focus on the pi star transition. So cis trans isomerization is also very important. So look at here. This is the trans stilbene and cis stilbene. What happened here? This is the trans, another one is cis. So what is the properties? You can see 295 nanometer and 276 nanometer. So if you have transitions trans, then you have higher lambda max value, and epsilon you can see much more in comparison to cis stilbene. So huge differences between cis trans, and how it is happen in the presence of light due to pi star transition. You can see another examples. You can look at here 93% and 7%. Cis we have 93% and trans only 70%, 7% trans stilbene. So if you have cis stilbene and trans stilbene undergo irradiations, and if you shine light on these molecules, singlet cis stilbene and singlet trans stilbene, then triplet cis stilbene and triplet trans stilbene, which is converted into triplet these products, and then cis stilbene 93% and trans stilbene only 7%. Look at another examples here. Now you can see how Br radicals give. Now dimerization reactions. You can see this is the Acetone sensitized photodimerizations of norbornene. This compound is norbornene. So you can see here dimerization reactions of norbornene. This compound is non-bornene compound. What happened here? You can see S0 to S1. Now you can see the T1 intersystem crossing. Then you can see the T1 of alkene and S0 of alkene. So there are different energy level of sensitizer and alkene. So for examples, here 32 undergo light radiation, singlet, intersystem crossing, triplet, and formation of radicals. You can see the formation of 33. In the same way, you can see cyclobutadiene undergo irradiation reaction. It gives the cyclized product 3-member ring and 4-member ring. Another examples, you can see 34 undergo reaction with methanol, forming these two products in presence of xylene. Now these two compounds undergo reaction with benzophenone at 330 nanometers. It will give 3 product of dimeric form. Now photochemistry of butadiene. You see the S-trans butadiene and S-cis butadiene, 95% and 5%. What happened here? You can see the reactions with light, formation diradicals and formation of diradicals, and this both compound undergo H-nu. It gave 35 and 36. So S0 and S0, this compound gave S0 and S0 with different products. Same thing happened in this type of molecules. So dimerization in presence of sensitizers. You have 37, 38 and 39. All these three compound is dimerized products. So benzophenone and benzyl. You can see benzophenone 69, 80, 16 and 4, and benzyl 54, 49, 8 and 43. Sensitizer. So this is the differences. Look at here. Sensitizer triplet tested, it transfer their energy to the dienes. Now look at the beautiful reactions of transition state, how dimerization occurs. You can see the another examples. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.